Hello. Today we'll be discussing the SPARCS experiments. Right now we're standing in the back of the Nuclear Radiation Lab at the Center for Plasma Material Interaction. SPARCS is right here. It stands for Surface Plasma Arc for Radiofrequency Control Study, and I hope you enjoy it. A basic explanation of the SPARCS experiments would be that we explore high voltage breakdowns in a vacuum to determine what causes them and how to prevent them. What we do is we place two electrodes inside of the chamber and pump it down to a very low pressure. Once it's there, we slowly increase the voltage up until a breakdown occurs. And then we take the image of that breakdown, the current and the voltage curve, and we save it to the computer so we can study it in the future and compare it to previous experiments and see how we can improve on this. This is very useful for ICRF antennas and fusion devices. The ICRF antennas are used to superheat the plasma to a point at which fusion can occur. We'll begin discussing the setup of the experiment by first discussing the electrical system. Right here is our high voltage power supply. It gets us to approximately 15 kilovolts, which in the high voltage power supply charges the capacitor bank located underneath the experiment. Here's the high voltage probe, which we use to measure the voltage as the experiment runs. And over here, we have the shunt resistor. The shunt resistor measures the currents through the experiment. And that concludes the electrical system. The next system we're going to discuss will be the vacuum system. Right here is the roughing pump. We use it to get the chamber down to about 10 millitorr. Here is the turbo pump. We use the turbo pump to get it down to about 10 to the minus 9 torr or so. Up here is how we measure the pressure. This is the convectron. It's good for relatively high pressures. Here's the ion gauge, which is used for much lower pressures. Finally, we'll begin discussing the miscellaneous measurement systems of the experiments. Over here, we have the linear motion feed through. It measures the contact distance between two electrodes inside the chamber. Here, we have the thermocouple, which measures the temperature. And finally, we have the grand setup. This is the voltage measurement, this is the current measurement, and this is how we capture the breakdown images. The next stage of the experiment we will discuss is how to repair the aluminum electrodes. We first begin by attaching it to a specialized drill bit on this drill press. Now, it's somewhat dangerous, so we attach eyeglasses, as well as protective gloves. We use two grits of sandpaper, a coarser grit and a finer grit. We start with the coarser and then work up to the finer. We start at the very center, slowly pulling back. Not putting too much pressure on, just enough to barely skim the surface. This is a long process. This will take anywhere from 15 to 20 minutes, so we're only going to show the small segment right now. After we've sanded the electrode, we bring it over to this station, where we rinse it off in just regular tap water first, to remove any sort of aluminum dust that may have stuck to the surface while we sand it. We have a little bit of Dawn soap from the top, and gently work it out. This should remove most of the contaminants that might have been stuck on the surface from previous uses. Rinse it off very thoroughly, and once we're done here, we'll move back over to the SPARCS experiment to the next station. Next, we bring the electrode here, where we wash it in a bath of isopropyl alcohol, acetone, deionized water, acetone again, and an IPA again. After we're done here, we bring it over to the nitrogen gun and gently freeze it off so that there are no contaminants placed on the surface of the electrode when we're done. Now we'll begin going over how we repair the second of the two electrodes, the copper electrode. When it comes out of the chamber, it looks something like this. There should be some marks and imperfections on the surface that were caused by the breakdown. We take it across the street to the Material Research Lab, where we wet sand it in the sand preparation room until the surface looks exactly like this. You'll see it's not quite as shiny, not quite as nice, which is why we bring it back over here to the electropolishing station in the chemical lab. We dip it in acid and we run a current through it. It's a process called electropolishing, and when it's done, the surface is much smoother, much shinier, and it's exactly what we want for our experiments.